First of all, I welcome all the students and the participants who are attending this live lecture. See this, in this live lecture today we shall discuss the solution of a homogeneous differential equation with the variable coefficients. See this, in the last lecture actually we have started the differential equation with the variable coefficients, and we have seen that the differential equation with the variable coefficient having two forms, homogeneous differential equation and it is a non-homogeneous differential equation. And see this, it is very important, all these types are belonging to the linear differential equation. Linear differential equation with variable coefficient. It may be homogeneous, it may be non-homogeneous. तो लास्ट के लेक्चर में हमने वो जो इनिशियल वैल्यू प्रॉब्लम्स के बारे में जो भी थ्योरम्स थे उसको भी डिस्कस किया है. आज हम होमोजेनियस इक्वेशन, वी हैव टू डिस्कस होमोजेनियस इक्वेशन, solution of the homogeneous equation, how to solve the homogeneous equation. See this, before starting the linear differential equation of order n with variable coefficients can be represented by a0x into y raised to n, means dny by dx raised to n, plus a1x y raised to n minus 1 plus a2x y raised to n minus 2 dot 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 in this way, plus an of x y is equals to bx. This is a non-homogeneous linear differential equation of order n which are variable coefficients. These are the homogeneous differential. This is example of homogeneous differential equation with variable coefficient. This is non-homogeneous example of a non-homogeneous differential equation with the variable coefficients. Okay. Now see this. 1 minute. Okay. And now let us start the next one theorem. In the last lecture we have seen two different theorems. Ganesh Kale, Pragati, Trapti Gaun, Sambhaji Jadhav, Maya Wakade, Samrin Khan, Rutuja, okay, Sangeeta Hapse, Sneha Gaikwad, Priya, Nandini Arte. Okay. Now we shall discuss the third theorem, that is uniqueness of the solution. In the last lecture we have seen the two theorems based on the homogeneous or non-homogeneous differential equation with the variable coefficients. But here in this case we shall discuss the uniqueness theorem. What is meant by the uniqueness theorem? Let x naught be an initial point, suppose, which is in the interval I, and alpha 1, alpha 2, alpha 3 dot 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 alpha n be any n constant, then there is at most one solution phi of L of y is equals to 0 on I satisfying phi 1 of x naught is equals to alpha 1, phi dash of x naught is equals to alpha 2 dot 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 phi raised to n minus 1 of x naught is equals to alpha n. Also it is called as a initial value problem. It is also called as initial value problem. This type of a theorem we have seen in the first unit also for differential equation with nth order having a constant coefficient. Also we have seen in the theorem differential equation of order 2 having a constant coefficient. So this is only the for variable coefficients. So we shall discuss this. Let phi and psi be the two solutions of L of y is equals to 0 on satisfying the condition phi of x naught is equals to alpha 1, phi dash of x naught is equals to alpha 2 dot 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 phi raised to n minus 1 of x naught is equals to alpha n. This is the given condition, or it is also called as the initial condition. Suppose that there are two solutions. Which are those? Alpha and psi. Actually we have to prove that according to the theorem. According to the theorem, actually we have to prove that there exists only one solution. But proof of this theorem we can take in the contradiction form. We consider there exist two solutions. First is phi, second is a psi of L of y is equals to 0, which satisfies all these initial conditions. That means both the solutions satisfies these initial conditions, that is phi of x naught is equals to alpha 1, phi dash of x naught is equals to alpha 2, psi of x naught is equals to alpha 1, psi dash of x naught is equals to alpha 2 in this way. Suppose that the difference between that solution, see this, we consider the difference between that solution is, suppose this is x-axis, this is y-axis. Suppose this is a phi is one solution, psi is another solution. There are two solutions, and we suppose that there and x naught be the initial condition. Suppose that chi be the difference between them. Chi means the difference between them. Suppose, 1 minute. Suppose chi is equals to phi minus psi is the difference between the both solution. We have to prove that chi of x, अगर आपको यूनिक सॉल्यूशन दिखाना है तो phi is equals to psi दिखाना होगा. अगर phi is equals to psi दिखाना है तो दोनों पॉइंट कोइंसिडेंट पॉइंट दिखाने पड़ता है. We have to show that phi and psi both points must be coincident, then we can say that it has a unique solution. अगर difference हमने chi is equals to phi minus psi, if we want to show phi is equals to psi, then we have to show that chi is equals to 0. That means chi of x is equals to 0. Now see this, let x be a point on I, then other than OTHER, other than x naught. Suppose x is another point which is other than x naught. Okay. Let J be any closed bounded interval on I such that which contains x naught and x. Suppose this interval is considered as I. Suppose this interval is considered as I. Now we consider the another interval, suppose which contains the points I and j, sorry, x naught and x, which is contained in j. So, okay. Be the closed bounded interval in I which contains x naught and x. See this. On this interval the function aj are bounded, that is mod of aj of x which is less than or equals to bj. We have seen in the previous theorem, theorem number 2, for j is equals to 1, 2, 3 dot n. For j, on j for some constant bj, then by the theorem the function cannot defined on j, the function cannot defined on j. Okay, that this implies that L of chi which is equals to 0. This implies that L of chi which is equals to 0 on j, and chi of x naught or absolute value of x naught or norm of x naught is equals to 0. This implies that norm of x naught is equals to 0. We have seen this theorem number 2nd. According to the theorem number 2nd, we have seen that chi of x, L of chi is equals to 0. So norm of chi of x naught is equals to 0. This implies that norm of x is equals to chi of x is equals to 0. This implies that अगर chi is equals to 0 होता है, इसका मतलब ये 0 होता है. अगर chi is equals to 0, then we can say that 0 is equals to phi minus psi, and this implies that phi is equals to psi. This shows that, see here, this shows that phi of x is equals to psi of x, and there is no difference between phi and psi. This shows that there exists a unique solution. This shows that there exists a unique solution, and this completes the theorem. परत एकदा सांगतो रे स्टुडंट्स, मी परत एकदा सूचना देतो. रेग्युलर आपल्याकडे 25 ते 30च मुलं राहतात, आपल्याकडे 80चं ॲडमिशन आहे. आता तुम्ही जेव्हा परीक्षेला याल तेव्हा तुम्हाला हॉल तिकीट दिलं जाणार नाही, लक्षात ठेवा. ज्यांची प्रेझेंटी नाही ना त्यांना हॉल तिकीट कुठल्याही परिस्थितीमध्ये दिलं जाणार नाही. तुमच्या परीक्षेचा टाइम टेबल लागला का? माधुरी पवार, MSc फर्स्ट इयरच्या एक्झामचा टाइम टेबल आला का? जे विद्यार्थी क्लास करणार नाहीत त्यांना बिलकुल परीक्षेला एक्झामला अलाउड केलं जाणार नाही. ठीक आहे. नाउ solution of the homogeneous differential equation. We can consider the different methods for the solution of the differential equation. Okay. Now see this solution of the differential equation. First of all, I write some theoretical part in that solution of the differential equation. See this. If suppose phi 1 comma phi 2 comma phi 3 dot 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 phi n be any m solutions of nth order differential equation L of y is equals to 0, because here we have considered the solution of homogeneous differential equation. माधुरी पवार म्हणजे याचा अर्थ माधुरी पवारला मी क्वेश्चन केला होता आणि ती नाही आहे, याचा अर्थ तिनं फक्त प्रेझेंटी टाकून गेलेली आहे. हा ना, बरोबर आहे. नाही लागला का? नितीन पवार, टाइम टेबल लागला नाही का रे? स्नेहल कदम स्नेहल आहे का? ठीक आहे, टाइम टेबल नाही लागला. मला पाहायचं असतं कोण क्लास करतं काय नाही. ऑन interval I and suppose C1, C2, C3 dot 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 Cn are any constant, then we can write L of C1 phi 1 plus C2 phi 2 plus dot 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 plus Cn phi n, which is equals to C1 L of phi 1 plus C2 L of phi 2 plus dot 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 plus Cn L of phi n. Okay, which implies that, this implies that, what we can say that C1 phi 1, C2 phi 2 plus dot 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 plus Cn phi n, Cn phi n is also a solution of the linear differential equation. Solution of the differential equation. Now we have consider, see this, इस तरह के solution को हम solution of differential equation बोलते हैं. It is the linear combination of phi and C1, which is the linear combination of phi and C1. Phi 1, phi 2, phi 1, phi 2, phi 3 are given by the characteristics equation. See this, the trivial solution is the function which is identically zero. See this, which is identically 0. So on I, what is meant by trivial solution? It is the identically 0 in I. Okay. if in the case of an L, see this, with a constant coefficient, every solution of L of y is equals to 0 is a linear combination of any n independent solution. Linear combinations of any n linear independent solutions, and that are C1 phi 1 of x plus C2 phi 2 of x plus dot 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 plus Cn phi n of x, which is equals to 0, where C1 C2 C3 dot 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 Cn. इथं तसं नाही पहा, इथं काय फरक असू शकतो, ई फाय 1 फाय 2 फाय 3, अगर nth ऑर्डर डिफरेंशियल इक्वेशन है तो वहां पे n इंडिपेंडेंट सॉल्यूशन भी होते हैं, नहीं भी होते, यहाँ पे m भी लिख सकते हैं. सी दिस, यू कैन राइट ऑल्सो हेयर m, इट मे बी m सॉल्यूशन्स, nच असावं असं काही नाही, m सुद्धा असू शकतात. इट मे बी m सॉल्यूशन्स, यू कॅन टेक दिस m, म्हणजे तुम्हाला फरक लक्षात येईल. इथं n च्या जागी m घ्या, nth order differential equation. So this is a m, and it is a trivial type solution. Solution of a homogeneous differential equation with a variable coefficient is of the trivial type solution. What is meant by trivial type solution? The trivial solution is the function which is identically 0 on I. Say this, okay? ठीक है. Now we shall discuss one by one theorem. What is that theorem? See this, theorem number 4. There exists a linear independent solution of L of y is equals to 0 on I. There exist n linearly independent solutions of L of y which is equals to I. See this. Now we consider proof. Let x0 be a point in I, which is suppose initial point. Then according to the theorem first, or given theorem 1 in this chapter, there is a, suppose this is a theorem, 1 minute, theorem 4, numbering आपण change करू. Suppose this is a, 1 minute, let x naught be any point in I. According to the theorem 1 which we have studied in this chapter, there is a solution phi 1 of L of y satisfying the initial condition phi 1 of x naught is equals to 1, phi 1 dash of x naught is equals to 0, phi 2 dash of x naught is equals to 0 up to the phi 1 of n minus 1 of x naught is equals to 0. Means only one, phi 1 of x naught is equals to 1. In general, for I is equals to 1, 2, 3 dot dot dot, there is a solution phi I. There is a solution phi I which satisfies phi I raised to I minus 1 of x naught is equals to 1. ही खूप महत्वाची कंडिशन आहे पहा. And remaining all, that is phi I raised to j minus 1 of x naught, remaining all solutions are zeros. Only one that solution is 1. Okay, here I is not equals to 0. Suppose this is equation number 4.1. Consider this is actually theorem number 4. So consider this equation as a 4.1. अगर 4 theorem में है तो इसके equation generally 4.1 दिखाना है. Now the solution phi 1 comma phi 2 dot 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 phi n are linearly independent on I. Suppose there are constants C1, C2, C3 dot 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 such that C1 phi 1 plus C2 phi 2 dot 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 plus Cn phi n, which is equals to 0. Suppose this is equation number 4.2. See this, we consider this equation number as a 4.2. Now see this, all the differencing for all x in I differentiating with respect to x, then we get C1 phi 1 dash of x plus C2 phi 2 dash of x plus dot 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 Cn phi n dash of x, which is equals to 0. अगर आप इसको डिफरेंशिएट करते हैं, इस इक्वेशन 4.2 को अगर आप डिफरेंशिएट करते हैं, then you will get the result that C1 phi 1 of x plus C2 phi 2 of x in this way. Similarly, again we can take the second order differential, we can take similarly third order differential up to the n minus 1th order differential equation, up to the n minus 1 differential equation, then we get C1 phi 1 raised to n minus 1 of x plus C2 phi 2 raised to n minus 1 of x plus dot 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 Cn phi n raised to n minus 1 x. Suppose this is equation number 4. Okay, I shall repeat this. For all x in I, in particular the equation 4.2, 4.3 must hold at x naught, x0. Now putting x is equals to x naught in 3.4.2, then we find using 3.1, that is of 4.1, that C11 plus remaining terms are all goes to the 0. So we get the C1 is equals to 0. Putting x is equals to x naught in the equation 4.3, see this, it wrong zale jara, 4.3, then we obtain the values of C1, C2, C3 dot 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 Cn, and thus we get the particular solutions. The phi 1, phi 2, phi 3 are the linearly independent solution. Okay, thus we can obtain the linearly independent solution. ठीक आहे, मी परत एकदा सांगतो, थेरम खूप सिंपल आहे, काय अवघड नाही आहे. There exists n linearly independent solution of L of y is equals to 0. This is the statement of the theorem, or we can write, याला असं सुद्धा लिहितात, prove that there exist n independent solutions of L of y is equals to 0. See this, let x naught be a point on I according to the theorem 1. आपण theorem 1 मध्ये पाहिलेला आहे, पहा theorem 1 ची स्टेटमेंट काढून पहा. There exists a solution phi 1 of L of y satisfying phi 1 of x naught is equals to 1 and remaining all derivatives phi 1 dash of x naught, phi 1 dash of x double dot of x naught, phi 1 triple dash of x naught is equals to 0. Means phi 1 of x naught is equals to 1 and remaining first order derivative, second order derivative, third order derivative goes to the 0. Okay. In general, आता यालाच आपण जनरली असं लिहिलो, phi 1 of x naught is equals to 1 असेल तर याला जनरली आपण असं लिहू शकतो, here I is equals to 1, 2, 3, 4 dot dot in this way. मग there is a solution phi I, जनरल कसं लिहिलं जातं. आता इथं पहा, I च्या जागी जर 1 ठेवलात phi 1, see this, हे कसं आलं सांगतो, I च्या जागी जर 1 ठेवलात तर phi 1, परत इथं I च्या जागी 1, 1, 0, I1 आहे ना, 1 ठेवलात 1, 1, 0, मग phi 1 of x naught, ठीक आहे, phi 1 of x naught is equals to 1. ओके, आता इथं सिमिलरली जे च्या जागी जे म्हणजेच काय घेतलं जाईल तुम्ही, जे इज नॉट इक्वल्स टू आय, मग बाकी कोणतेही घ्या, सर्वच्या सर्व रिमेनिंग टर्म्स 0 असतात. म्हणजे एवढं लक्षात ठेवा, जेवढं सोल्युशन घ्यायला लागलात तुम्ही तेवढीच व्हॅल्यू तिथं 1 येणार, लक्षात ठेवा. मग इथं phi I, ओके, फर्स्ट ऑर्डर डेरिव्हेटिव्ह इथं ऑर्डर झिरोथ ऑर्डर इथं परत लक्षात आलं का तुम्हाला? हे डेरिव्हेटिव्हचं नोटेशन आहे, इंडेक्स नाही, लक्षात घ्या. समजा आपण फाय टू आय इज इक्वल्स टू 2 ठेवला, समजा इथं आय इज इक्वल्स टू 2 ठेवू, तर कसं होतं? फाय टू ऑफ एक्स नॉट 2 मायनस 1 आयच्या जागी 2 ठेवला तर फर्स्ट ऑर्डर डेरिव्हेटिव्ह होतो, तो म्हणजे डॅश. फाय टू ऑफ एक्स नॉट इज इक्वल्स टू 1, बाकी सर्वच्या सर्व काय असतात? 0. फाय टू डबल डॅश ऑफ एक्स नॉट इज इक्वल्स टू 0. फाय टू ट्रिपल डॅश ऑफ एक्स नॉट इज इक्वल्स टू 0 इन दिस वे. म्हणजे हे तुम्ही इंडेक्स समजू नका, हा डेरिव्हेटिव्ह आहे, डेरिव्हेटिव्ह. म्हणजे तुम्हाला जर इथं मी असं सांगितलं आय इज इक्वल्स टू 1 ठेवा, 1 ठेवलं तर काय होतं पहा? फाय 1 आय मायनस आय, सॉरी 1 मायनस 1 म्हणजे 0. इट्स झिरोथ ऑर्डर डेरिव्हेटिव्ह, म्हणजे डेरिव्हेटिव्ह नाही घ्यायचा. एक्स नॉट इज इक्वल्स टू 1, रिमेनिंग ऑल आर 0. फाय 1 डॅश ऑफ एक्स नॉट इज इक्वल्स टू 0. आता आय इज इक्वल्स टू 2 ठेवा. म्हणजे अशा पद्धतीनं, या पद्धतीनं तुम्ही कुठलंही जर सोल्युशन घेतलात तर त्याचा रिझल्ट सेम येतो, याच पद्धतीने येतं, लक्षात घ्या. ठीक आहे, असं हे तुम्ही पाहू शकता. त्यानंतर फर्स्ट ऑर्डर डेरिव्हेटिव्ह घ्या, सेकंड ऑर्डर डेरिव्हेटिव्ह घ्या, थर्ड ऑर्डर डेरिव्हेटिव्ह घ्या. जेव्हा फर्स्ट ऑर्डर डेरिव्हेटिव्ह घेतात तेव्हा तो 1चा परत 0 होतो, टर्म्स रिड्यूस होत जातात. सेकंड ऑर्डरपासून राहतात, थर्ड ऑर्डरपासून राहतात, आणि शेवटी मग या पद्धतीने हे इक्वेशन आपल्याला सॅटिस्फाय मिळतं. ठीक आहे, हे थेरम सिंपल थेरम आहे, फक्त जनरल आयडिया आहे. थेरम म्हणजे जनरल आयडिया. ॲक्च्युअली इन दिस थेरम वी हॅव एक्सप्रेस्ड द जनरल आयडिया अबाउट द n linearly independent solution. Okay, now next we shall discuss the theorem number 5. Let phi 1 comma phi 2 comma phi 3 dot 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 phi n be the n constants of L of y is equals to 0 on I, satisfying the condition, same condition, see this, satisfying the general condition according to the theorem. See this, according to the theorem 4.1, 1 minute, 4.1, 4.2. According to the condition of the theorem 4.1, we have written here, see this, satisfying the condition phi I raised to n minus 1 of x naught is equals to 1, and remaining all are 0. Phi I raised to j minus 1, I is not equals to j, of x naught is equals to 0 for I is not equals to j. If phi is any solution of L of y on I, there is n constants c1, c2, c3 dot 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 cn such that phi is equals to c1 phi 1 plus c2 phi 2 plus c3 phi n dot 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 in this way. अभी यहाँ पे क्या सोल्यूशन प्रूव करना है? देखो, लेट phi 1 comma phi 2 dot 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 phi n be the n constants of L of y which is equals to 0 on I, satisfying the condition phi I raised to I minus 1 of x naught is equals to 1. फक्त एक सोल्युशन 1 असेल, इंडिपेंडंट सोल्युशन phi ची व्हॅल्यू 1 असेल, बाकीचे सर्व 0. phi I raised to j minus 1 of x naught which is equals to 0 for I is not equals to j. If phi is a solution of L of y is equals to 0 on I, then there is n constants such that c is equals to c1, c2, c3 dot 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 cn such that phi is equals to c1 phi 1 plus c2 phi 2 plus c3 phi 3 dot 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 cn phi n. As like we have seen the theorem in the homogeneous differential equation of the or constant coefficient. Okay, now see this, let phi of x naught is equals to alpha 1, phi dash of x naught is equals to alpha 2 dot 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 phi raised to n minus 1 of x naught is equals to alpha n. But generally according to the theorem, remaining phi 2, phi 3, phi 4 dot 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 phi n goes to the 0. See this. Let consider the function psi, which is given by phi 1 c1 alpha 1 phi 1 plus alpha 2 phi 2 plus alpha 3 phi 3 dot 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 alpha n phi n, which is equals to 5.1. This is the solution of L of y is equals to 0. Suppose this is equation L of y is equals to 0, because phi 1 of x naught is equals to alpha 1, phi dash of x naught is equals to alpha 2. In this way, phi raised to n minus 1 of alpha naught is equals to alpha raised to n. So, psi of x naught is equals to alpha 1. अगर ये solution है, psi is a solution of L of y is equals to 0, then according to the initial condition we can write psi of x naught is equals to, x naught is satisfying this equation. So, psi of x naught is equals to alpha 1 phi of x naught plus alpha 2 phi of x naught, phi 2 of x naught plus alpha 3 phi 3 of x naught, means phi x naught satisfying the solution, because x naught is one of the solution. So, suppose this is equation number 5.2, but given that, but according to the initial condition we have given that phi of x naught is equals to 1. See this. According to this statement, see this. According to this statement, we have given that phi 1 of x naught is equals to 1 and other solutions are 0. So, we can use there, according to the given condition in the theorem, phi 1 of x naught is equals to 1. Then remaining are all the solutions are 0. एक minute. See this. So, we can say that remaining all are 0. So, we can write, put this value, this is a 0, again this is a 0, in this way both are the zeros. So, alpha 1 into 1, see this, means psi of x naught is equals to alpha 1. Thus, we get psi of x naught is equals to, suppose alpha 1 or alpha, then psi dash of x naught is equals to alpha 2 dot 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 psi raised to n minus 1 of alpha naught is equals to alpha n. Thus, the psi is a solution of L of y is equals to 0 at x is equals to 0, having the same initial condition x naught as phi. म्हणजेच phi सारखी same initial condition psi ला आहे. मग psi is a solution, then we can say that phi is also solution. psi ला जर कंडिशन x naught ची satisfy होत असेल initial condition psi साठी, which is as like a phi. So, therefore, by the theorem we can say, if chi is equals to 0, then phi and psi are equal. We have proved in the theorem number 4, theorem number 3. So, we must have phi is equals to psi. This shows that phi is equals to alpha 1 phi 1 plus alpha 2 phi 2 plus dot 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 alpha n phi n. By taking alpha 1 is equals to C1, alpha 2 is equals to C2, alpha dot 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 alpha n is equals to Cn, then we get this solution as phi is equals to C1, we get C1 phi 1 plus C2 phi 2 plus dot 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 Cn phi n, and hence we have proved the theorem. Now we shall discuss the examples based on this. Now examples, problems, examples. Before starting the special case, note, इथे एक note घेतो मी, note. We can use the solution. The solution of linear differential equation of variable coefficient in the form. आता एक पर्टिक्युलर केस आहे एक्झाम्पल सॉल्व करण्यासाठी, या मेथडपेक्षा शॉर्टकट मेथड वापरता करता येते. पर्टिक्युलर केस that is special case. हा कुठला आहे? Suppose we can consider a0 x raised to n y raised to n means nth order derivative plus a1 x raised to n minus 1 y raised to n minus 1th order derivative plus dot 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 plus a_ny which is equals to suppose x or whatever may be 0, we consider 0. अगर लीनियर होमोजेनियस है तो 0, नॉन होमोजेनियस है तो x भी कंसिडर कर सकते हैं. तो इसके लिए सॉल्यूशन अगर हम होमोजेनियस और इट इज इक्वल्स टू x, ये भी हो सकता है. सो हाउ टू सॉल्व दिस इक्वेशन? पुट, see this, how to solve? Put dy by dx, y raised to n means actually dy by dx, d is equals to dy by dx, d by dx we consider, or dy by dx we consider d by dx, and also we have to put x is equals to e raised to z. This implies that log यालाच आपण असं सुद्धा लिहू शकतो log x इक्वल्स टू z. मग हे ऑपरेटर इक्वेशन कसं बनतं पहा. त्यामुळं मग काय होतं पहा, therefore dy by dx can be written as dy by dx means we have considered d by dx, dy by dx, okay, dy by dz into dz by dx by the chain rule. ही एक तुम्हाला टेक्निक सांगायला लागलो शॉर्टकटची. ओके, dy बाय dz, आता dy बाय dz म्हणजेच काय येतो पाय, दिस इम्प्लाइज dy बाय dz, हां dz बाय dx, dz बाय dx इक्वल्स टू लॉग x चा डेरिव्हेटिव्ह काय असतो 1 बाय x, dz बाय dx मीन्स 1 बाय x इंटू 1 बाय x इंटू dy बाय dz. See this, 1 by x into dy by dz. बरोबर आहे. मग आता इथं x इकडे घ्या, therefore x into dy by dx which is equals to dy by dz. आता dy by dz ला आपण d कन्सिडर केला तर इथं x into dy by dx ची जी टर्म असते यालाच आपण असं लिहू शकतो xd. याला असं सुद्धा लिहिता येतं x into d, d means dy by dx, suppose this is dy which is equals to suppose d1, where d1 is equals to dy by dz, dz by dx, dz by dx, d म्हणजे काय घेणार तुम्ही, d by dz, हाँ dy by dz, 1 minute, so dy by dz, एकच मिनिट, dy by dz. मग अशा पद्धतीनं सबस्टिट्यूट करा. सिमिलरली x स्क्वेअर ही फर्स्ट ऑर्डर टर्म झाली. सिमिलरली आता इथं जर x स्क्वेअर इंटू d2y बाय dx स्क्वेअर असेल, that can be replaced by, this implies that x square into d square which is equals to, आता x square into d square आला तर त्यालाच आपण असं लिहू शकतो d square minus d, d1 square minus d of y. या पद्धतीनं लिहिता येतं. सिमिलरली वी कॅन राईट x क्यूब, x raised to 3 अशा पद्धतीनं लिहिता येतं. दॅट कॅन बी रिटन एज d1 इन अ ब्रॅकेट d मायनस d1 आणि मग सोल्युशन काढून, सॉरी d1 मायनस d, d1 मायनस 1 ऑफ y अशा पद्धतीनं सोल्युशन काढून सेकंड ऑर्डरची, या पद्धतीनं nth ऑर्डरसाठी सुद्धा असंच लिहिलं जातं. डॉट 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 x raised to n into dny by dx raised to n असेल. This implies that x square into d raised to n, which is represented by d into d1, d1 minus 1, d1 minus 2, dot dot dot, d1 minus n plus 1 of y, and substituting all these values in equation 1. इक्वेशन 1 मध्ये ठेवा आणि मग d1 चा characteristics polynomial find out करके then we get the equation in the form of d1 is like in the form of d1 च्या जागी d चा फॉर्म येतो आणि मग अशा पद्धतीचे सोल्युशन घेता येतात. सी दिस. आता याचं एक्झाम्पल घेऊ. प्रॉब्लेम ही स्पेशल केस आहे, त्या मेथडनं जाण्यापेक्षा ह्याला आपण दुसऱ्या पण मेथडनं घेणार आहोत, पण तुम्हाला माहित राहावं म्हणून घ्यायला लागलो. सी दिस. सॉल्व the following differential equation. First, x square into y double dash plus x into y dash minus 4 into y, which is equals to 0. Means this is is like this equation. अभी देखो इसके ऑर्डर कितने हैं? सेकंड ऑर्डर है, उसका जो कोएफिशिएंट है एक्स स्क्वायर. फर्स्ट ऑर्डर टर्म है, उसका कोएफिशिएंट एक्स, एंड द कांस्टेंट टर्म है, इसका कोएफिशिएंट कितना है? 4. सो गिवन डिफरेंशियल इक्वेशन इज x square into d2y by dx square plus x into dy by dx minus 4y, which is equals to 0. Okay, now this can be written as, यालाच आपण dy by dx. Now put capital D is equals to dy by dx, or we can write notation d by dx. असं सुद्धा नोटेशन लिहितात. dy by dx लिहायची सुद्धा गरज नाही. d by dx नोटेशन आपण फक्त d by dx सुद्धा लिहितो. Also, how we can write? Then we get the equation. This implies that, therefore, we can write x square d plus x into d minus 4 of y, which is equals to 0. Suppose then equation 1 becomes, now put, suppose x is equals to e raised to z. This implies that z is equals to log x. Therefore, dz by dx is equals to log x चा डेरिव्हेटिव काय होता है रे? 1 होतो. 1 सेम प्रोसेस मध्ये log x चा डेरिव्हेटिव 1 होतो. मग आताच पाहिलेलं आहे आपण. हाऊ वी कॅन राईट? अगर x इज इक्वल्स टू ई रेज टू झेड पुट करते तो x d ला आपण d1 लिहू शकतो. x स्क्वेअर d स्क्वेअर ला d1 into d minus 1 of y लिहू शकतो. So therefore this implies that now xd can be written as a d1, x square d square can be written as d1 into d1 minus 1. Okay, so put these values in equation 2. इसको हमें अभी 2 में रखना है. 2 में. Okay, then we get, put in 2. अभी देखो क्या आता है 2 में. x square d square येतो इथे. लक्षात ठेवा d2y by dx square आहे. See this is a x square as it is. Again d2y by dx square म्हणजेच डी स्क्वेअर प्लस एक्स डी मायनस 4 ऑफ वाय. त्याची अडचण नाही, हे ऑपरेटर इक्वेशन म्हणतात त्याला. ठीक आहे. सो d1 into, we can write this as x square d square means d1 into d1 minus 1. Second, x into d means d1 plus d1 minus 4 of y, which is equals to 0. So d1 square minus d plus d minus 4, which is equals to 0, of y, which is equals to 0. So plus d1 minus d1 get cancelled, that is a d1 square minus 4 is equals to 0. So I is like the characteristics equation. Now we can represent this in the form of a characteristics equation. So this is the characteristics equation. So in the form, the characteristics, the form of a characteristics, or we can calculate directly character. Now we have to solve this. This is equation in terms of z. This is in the form f of d1 of y, which is equals to, suppose 0, right side is 0. So the characteristics polynomial is p of r square minus 4 is equals to 0. So r square minus 4 is equals to 0. So r square is equals to 4. So r is equals to plus or minus 2. So we can write r1 is equals to 2, r2 is equals to, again we get the equation. What is that? Minus 2. बरोबर आहे का रे? This goes to the solution minus 2. So the required solution is, therefore the required solution is phi is equals to C1 phi 1 plus C2 phi 2. That means C1 e raised to 2x plus C2 e raised to 2x. But this is in the form of z. हे कशाचा फॉर्म आहे? z चा फॉर्म आहे, in the form of z. So we can write this as a z. 2z minus 2z. This is a form of d1, f of d1. d1 means which is a form of z, dz by dx. So we have write in the form of z. Replace the value of z. C1 e raised to 2 into log x plus C2 e raised to minus 2 into log x. That means C1 e raised to log of x square plus C2 e raised to log of x raised to minus 2. आता e चा power log f of x असेल, that can be written as a f of x. This is the formula for, because exponential function and logarithmic function with base e having the ratio inverse of each other. So we can write this. This is C1 x square plus C2 e raised to minus x square. C2 x raised to minus 2. This is the required solution of the given differential equation. This is the required solution of given differential equation. म्हणजे अशा पद्धतीने सॉल्व करायचं. d1 चं रूपांतर कशात करून घ्यायचं? d मध्ये करून घ्यायचं. आता इथं x स्क्वेअर d2y by dx स्क्वेअर means x स्क्वेअर d स्क्वेअर, x स्क्वेअर d स्क्वेअर. हाऊ टू कन्वर्टेड दिस x स्क्वेअर d स्क्वेअर? हे कसं कन्वर्ट केलं हे तुम्हाला सांगायचं झालं तर सेकंड ऑर्डर डेरिव्हेटिव्ह चेक करा तुम्ही. सेकंड ऑर्डर डेरिव्हेटिव्हवरनं होतो. सेम प्रोसेसमध्ये तुम्हाला सॉल्व करायचे. ही एक्स स्क्वेअर डी स्क्वेअर कसा कन्वर्ट होतो हे जर पाहिजे झालं तर सेकंड ऑर्डर डेरिव्हेटिव्ह घ्या. मी तुम्हाला हे वाटलं तर कसं होतं सांगतो. See this. Now we have d2y by dx square means which is given by d by dx of dy by dx, which is given by d by dx of 1 upon x dy by dz. So product rule वापरा, minus 1 upon x square into dy by dz plus 1 upon x into d2 d by dx of dy by dx, dy by dz. Again put this value, minus 1 upon x square dy by dx, dy by dz plus आता इथं परत 1 upon x into d by dx of 1 upon x into काय लिहिता येईल पहा, डी बाय डी एक्स डी झेड बाय डी एक्स, डी वाय बाय डी एक्स डी वाय बाय डी झेड, इथं डी बाय डी एक्स ऑफ डी वाय बाय डी झेड, डी वाय बाय डी झेड म्हणजे डी वाय बाय डी झेड इंटू डी झेड बाय डी एक्स. परत आता याची 1 अपॉन एक्स व्हॅल्यू ठेवा. 1 अपॉन एक्स व्हॅल्यू ठेवल्यानंतर हा एक्स स्क्वेअर लेफ्टला घ्या म्हणजेच तुम्हाला एक्स स्क्वेअर इंटू असं इक्वेशन मिळेल. सो वी गेट d2y बाय dx स्क्वेअर. तुम्ही सॉल्व करा, येऊन जाईल हे मायनस 1 अपॉन एक्स स्क्वेअर dy बाय dz प्लस 1 अपॉन एक्स स्क्वेअर d2y बाय dz square means x square d2y by dx square which is equals to minus dy by dz plus d2y by dz square. So x square into d square is equals to minus d1 plus d square. In this way we can write this way. y लिहिलं तरी चालतं, नाही लिहिलं तरी चालतं. ठीक आहे. तर अशा पद्धतीचे तुम्हाला होमवर्कला प्रॉब्लेम देतो, तुम्ही ते होमवर्कचे प्रॉब्लेम सॉल्व करा. सेम प्रोसेस आहे, होमवर्कचे प्रॉब्लेम सॉल्व करा. होमवर्क सर्वांनी सॉल्व करा रे. फर्स्ट एक्स स्क्वेअर इंटू वाय डबल डॅश मायनस 3x इंटू वाय डॅश प्लस 4y which is equals to 0. This is the first problem. Second problem, x cube y triple dash plus 2x square y double dash plus 3x dy by dx मायनस 3y विच इज इक्वल्स टू 0. हे लक्षात ठेवा. सेकंड ऑर्डर डेरिव्हेटिव्ह असेल, वाय डबल डॅश असेल तर एक्स स्क्वेअरच पाहिजे, तरच ही मेथड चालते. देन वी कॅन सॉल्व बाय युजिंग धिस मेथड. D1च्या मेथडनं सॉल्व करता येतं, शॉर्टकट मेथड आहे. आणि त्यानंतर पहा लास्ट आहे 1 मिनिट. थर्ड y double dash plus 1 upon x y dash minus 1 upon x square y which is equals to 0. See this, and एचा particular find particular solution if phi1 of x, phi1 of 1 is equals to 1 and phi1 dash of 1 which is equals to 0. C1 C2 च्या व्हॅल्यू कॅल्क्युलेट करण्यासाठी मी याची हिंट सांगतो. हिंट मल्टिप्लाय करून घ्या एक्स स्क्वेअर ना. सो वी गेट एक्स स्क्वेअर इंटू वाय डबल डॅश प्लस एक्स इंटू वाय डॅश मायनस 1 वाय विच इज इक्वल्स टू 0. हिंट आहे मल्टिप्लाइंग बाय एक्स स्क्वेअर. आता या फॉर्म मध्ये आला. पुट एक्स स्क्वेअर डी स्क्वेअर मीन्स d1 इंटू d1 मायनस 1 पुन्हा xd is equals to d1, and in this way we can obtain the solution as like the previous method, and then put phi 1 of x is equals to 1, phi dash of phi 1 dash of x is equal. इथं phi 1 च्या ऐवजी काय लिहा, phi लिहा, फक्त phi. इथं phi 1 of 1 अशा पद्धतीनं तुम्ही सॉल्व करा. phi 1 phi 0. ठीक आहे. पहा काय येतं सोल्युशन आणि